Okay, this is factoring by grouping, which we've never really dealt with before. Factoring by grouping is a special type of factoring. Actually, it's not really special. It's just one way of doing it. It's my wife's favorite, as she said back there, but it does always work. But here's the deal. Factoring by grouping, if there are four terms, here's basically what we're going to do. We're going to pair this up into two sections. Here's one pair, here's another pair. And we're going to divide out the biggest thing we can. So in this case, the first one we're going to divide out of 5z squared. 5z squared. And that'll leave us with a z plus 1. Okay? All I did was divide 5 divided by 5 by 1, x cubed divided by x squared to get z cubed divided by z squared to get z, and all that, and so forth and so forth. For this one, I'm going to divide out the biggest thing I can is a negative 6. When I divide out a negative 6, I get a positive z and a positive 1. Okay? So basically all I did is divide out the biggest thing I can out of the first two, and then divide the biggest thing I can. Oh, what did I just do? Okay, there we go. Out of the second two. All right? And then you notice how I have the same on both of those. Those are both z plus 1. All right, that's important. If they are not, you need to go back and see if you can divide by something else. You may not have to divide by the biggest thing. The point of this is to get the same thing on both sides. If you can hear that, I'm being summoned by my son. So I'll be right back. Okay, I'm back. No promises I won't be summoned again in a second. There he goes again. Anyways, so you notice how we've got a z plus 1 for both of those. Well, so what we're going to do is we're going to factor out a z plus 1 from the entire thing. So if I divide both terms, both the front term and the second term, by z plus 1, I'll have the factor z plus 1 out front, and then I'll have these two coefficients in the back.
Daddy. Wonderful.
Okay, and then, like I said, when we divide out the z plus 1, we're left with a 5z squared and a negative 6. So we got the 5z squared and a negative 6. All right, and this is our factored form right there. Another way to think about this, imagine if the z plus 1 was a big X. So let's say if we had 5z squared times x minus 6 times x. Okay, just I wrote in an x instead of the z plus 1s. Okay, I could easily think, oh, well, you know, I could divide both of those by an x. And like earlier, I would just throw it out front, and you'd have 5z squared for the first one minus 6 on the other one. X, 5z minus 6. Well, x, 5z minus 6. Right? It's the same idea, except I'm just dividing out an entire binomial. Okay? So here we go. Let's do number 18. 18, same idea. We're going to pair up the first two, and we're going to pair up the second two. And we'll get to the point where you have to kind of eventually pick two to pair up, but for the time being, we'll just put them in an order. We're getting you used to the pattern. So here we go. The first two, the biggest thing I can pull out is an a cubed. A to the third power. So a to the fifth divided by a cubed is a squared. And a cubed divided by a cubed is simply 1. All right. This one, you'll look at it and say, you know what, I can't divide anything out of both of those. This one doesn't have a number, that one doesn't have a letter. However, if I just leave it alone, then the signs won't add up. So I'm actually going to divide both of those by a negative 1. So I get, instead of a negative a squared, I get a positive a squared. And instead of a negative 1, I get a positive 1. All right? And now both of those say a squared plus 1. They are the same.
I make dots.
I love you too, buddy. We'll make dots later. So for right now, just like over here, when we divided out the two x's, think of those as two giant variables. The same thing. They're the same thing. So we'll divide them out, put them out front, a squared plus 1. And then when I divide it out, it cancels that one out, and I get an a cubed. And it cancels that one out, and I get a negative 1. So that is our factored form.
Hey, Daddy.
And actually, we can factor this one down further.
How do you make a dot?
How do you make a dot?
How do you make a dot?
All right, for the rest of this one, we're doing it in orange because my son wants to do it in orange. If you remember, this is a difference of cubes. So if I wanted to, I could factor this down further. A squared plus 1. A cube, the cube root of a cubed is a. The cube root of negative 1 is 1, so we'll put a negative 1 because it's negative. You just changed the color on me. And then we have a squared. Multiply the first, multiply the both, multiply the last. So it's a squared plus a, because that's a times 1, plus 1 times 1 is 1, so plus 1. So that would be the complete factored form for this one, if we were going that far. But for right now, we just want you to get there. We'll get to this eventually. Just know it's coming.
What's this?
At this point, I want you to try 19 and 20 on your own. Give them a shot. Pause the video and then come back, okay? I gotta...
Eli, you have to pick the color.
No. Don't pick the color. Stop that. Mommy's gonna... Stop.
I'm not doing that.
Okay, so for number 19, I just realized that I may have accidentally said chip for some, and my son is just going wild over there. I'm sorry. So, at this point, if I divide this first one by 5p, I get I get p squared plus 1. And divide this one by the biggest thing I can. Even if I pull out a positive 5 or a negative 5, I still get p squared minus 1. If I divide out a positive, I get a negative p squared plus 1. Alright, so what I'm going to do is I'm going to start off by switching these two. Okay? So I get 5p cubed minus 5p squared plus 5p plus 5. And now let's try it this way. So for the first one, I'm going to divide out a 5p squared. And I get p minus p plus 1. No, it's not plus 1.
No, it's minus 1 and plus 1. It's not going to work. It's not factorable.
This one is straight up not factorable at all.
No, it's not. Sorry to start over again.
Is there any way to factor this one?
No, that's why I said it shouldn't matter. Because under addition and subtraction, order doesn't matter on PEMDAS. Are you still recording? Positive 5.
Alright, so here's the deal. 5, p minus 1, and I pull out a 5, and a p plus 1. And again, we're still dealing with the same problem. So here's what we're starting to realize. Is the only thing we can factor out of this is a 5. P cubed plus p minus p squared plus 1. And that's as far as you can go. Sorry if I just sent you on a wild goose chase, but that's what it is. Mr. Hunter had to figure out as well. Maybe we'll change that for next year. I'm not sure yet. But we may leave it. All right, number 20. This one's not factorable. I don't know what I'm going to do while my son screams over there and plays with the dog. So, here we go. Let's take the first two. This one I'm going to pull out a t to the 5th. And we get 5t plus 2.
Hey, baby.
Put a parentheses here. And for this one, I'm going to divide out a negative t cubed, because that's the most number of t's I can pull out. And to make the signs the same, I got to change those. So that's why I'm pulling out a negative. So I got 5t plus 2. Okay? And now for this one, unlike the last one, we got the same thing twice. Alright? So, like before, I can divide out a 5t plus 2. I can factor that out. So, 5t plus 2, which will cancel both of those. And I'm left with a t to the 5th minus t cubed. Now, even so, I can go further than that. If we're still going, this one, I can divide it a t squared. So I'll pull out a t squared. 5t plus 2. And that would be t cubed, I'm sorry, not a t squared. That would be a t squared minus 1. And hopefully you realize that that is a difference of squares. So bring everything down. We got a t cubed, 5t plus 2